In this question, we're given a bracket containing x squared minus 1 over 2x, and the bracket is cubed, and we're asked to expand it. So let's see how we could do this. Well, before sort of A level, you would just be expected to expand this manually one bracket at a time, or one pair of bracket at a time. But at A level, we're going to use something called the binomial theorem. And in particular, initially, when we are dealing with the binomial theorem, it's easier to deal with Pascal's triangle version of the binomial theorem. And you may have seen Pascal's triangle is basically a triangle of numbers, and we get the numbers using a simple sort of algorithm, which is the boundary of our triangle is gonna consist of ones, and then the numbers in between are gonna come from the two of the closest numbers in the row above by summing them. So in particular, that 3 comes from a 1 plus 2, that 2 comes from a 1 plus 1, and so on and so forth. Okay. Now, what does this triangle tell us? This triangle essentially contains the coefficients, in other words, the numbers in front of the powers of a and b that are going to come out of expanding a plus b to the n. And the first row corresponds to the power 0, the second row corresponds to the power 1. So in other words, a plus b to the 1 is a plus b, but really the coefficient of a is 1, which is this one, and the coefficient of b is 1, which is this one. Likewise, a plus b squared is going to expand to give you a squared plus 2ab plus b squared. So the a squared has coefficient 1, the 2ab, this is the 2 being referenced in the 2ab, and the b squared is going to also have coefficient 1. So knowing that, what we can say is actually we know what the coefficients of a plus b cubed are going to be because we can read them off from our Pascal triangle. So to figure out the expansion x squared plus minus 1 over 2x all to the power 3, first of all, I can just write down the coefficients from my Pascal triangle. Okay, so we've done that here. And now you notice I've deliberately written x squared minus 1 over 2x as x squared plus minus 1 over 2x. The reason for that is because these things here in the Pascal triangle are really derived or worked out for the standard expansion a plus b to the n. So I've got to have a plus in the middle. So if the plus is not already there, like in this case, I rewrite it such that I actually get my plus artificially. Okay, so but once you've got to this stage, what we then do is we take the first thing in our bracket and we place it next to each one of our coefficients, like so. So the first thing for us happens to be x squared, and so we have x squared written out in front of each of our coefficients. And then we repeat this for the second thing. This is where this plus becomes important, because if that plus is not there, as I've said, we've got to artificially manufacture that plus, which means that when I take this, I have to take minus 1 over 2x and not 1 over 2x, okay? So we would then put minus 1 over 2x in front of each of our sort of coefficient terms that we've figured out. And so we've got the overall structure of what our expansion is going to look like. The only thing we now have to do is figure out what the powers on one of these brackets and the other bracket is going to be for each of these terms. And there's a simple pattern. So we essentially take the number on the left-hand side, which is the exponent of the bracket we're trying to expand, and we put that on the first set of brackets on the right-hand side, and then we reduce it by 1 for each successive bracket. Okay, so I go from 3 to 2 to 1 to 0, and you see that the power is on the same term. It's on the x squared term, okay? And now we repeat this, but we repeat it for the other bracket. But in this case, the powers are going to go the other way. So we're going to start from 0 and we're going to keep increasing by 1. So 0, 1, 2, and 3. And a sensible check at this stage would be the two powers should add up to give me the power that I'm trying to expand. Okay, so 3 plus 0 is 3. That's sensible. 2 plus 1 is 3. That's also sensible. 1 plus 2 is 3. That works. And lastly, 0 plus 3 is 3. And so this is basically our expansion, provided we just put these pluses in there, because we know that when we expand, there's a plus in the middle. So when the expansion happens, we're going to get lots of terms that are added up. And so at this stage, we're basically done in essence, because we've applied the binomial theorem, and anything from this point onward is really just simplifying and not really technically part of binomial theorem. But nevertheless, we must simplify because leaving things in this form is probably not going to get you all the marks on a paper. So we would simplify, and this is standard stuff. So x squared to the power cubed, well, we've got power to a power. We multiply 2 times 3 is 6, so we have that. X squared squared is going to give me x to the 4, but it's got to be multiplied by 3, so 3x to the 4. And then obviously the minus 1 over 2x term is still being multiplied. And then 3x squared is here, and minus 1 over 2x all squared. It's going to kill the minus. The numerator is just going to give me 1 because 1 squared is 1, and the denominator is going to give me 4x squared. Lastly, the x squared to the 0 term is just 1, so we need not even write it down. And then minus 1 over 2x cubed is minus 1 over 8x cubed. And we keep the coefficient, which is essentially 1. So really, we can simplify further, and we see that the x to the 6 is not going to change, but the 3x to the 4 times by minus 1 over 2x is going to give me minus 3 over 2. And then the x term is going to be x cubed because I've got x to the 4 divided by x. So I'm going to subtract powers. 4 minus 1 is 3. And likewise here, the 3 times by 1 is going to give me 3 in the numerator, and then there's just the 4 in the denominator, so I keep that 4. But then the 2x squared, so the x squared on the top and the x squared on the bottom are basically going to cancel out, so I'm just going to get a constant term. And lastly, 1 times by minus 1 over 8x cubed is just going to give me minus 1 over 8x cubed. So essentially, we have answered our question. We have expanded our bracket, and we have done so using the binomial theorem. And I hope you've taken away a little bit more than just the method of expanding in this question. And if you found this useful, then do consider subscribing.